Hello everyone. So in this class, we will see one more answer, that is what is orbital velocity. Obtain an expression for it. Again, this is 4-mark question from Gravitation chapter. What is orbital velocity? Obtain an expression for it. So first you have to define orbital velocity, and then we have to derive an expression for it, that is for VO. Let's see in detail. Now, first of all, definition. What is orbital velocity? The velocity required to put the satellite into its orbit around the Earth is called orbital velocity. Okay, around the Earth, whatever the velocity is required to put the satellite in one particular orbit, we can say that is orbital velocity. Now, expression. See the diagram. You can see this is the Earth whose mass is m and radius is r, and this is what satellite whose mass is small m, and it is revolving at height h above the Earth's surface, and orbital velocity is v0. So see, what is capital M? Mass of the Earth. Next, small m is mass of the satellite. v0 is orbital velocity. H is height of satellite above the Earth's surface, and this r plus h is orbital radius of satellite. Now, gravitational force on the satellite is, this is small m and this is capital M. So in between these two masses, you are having gravitational force. What is that? F is equal to gmm by r plus h whole square. G, mass of the Earth into mass of the satellite divided by this r plus h whole square. Now, centripetal force, as this satellite is moving with velocity or orbital velocity v0, it is having centripetal force, and that centripetal force is given by F is equal to m v0 square by r plus h. Now, at equilibrium, this centripetal force is equal to gravitational force, and that's why I'm going to equate these two. So see here, m v0 square by r plus h is equal to gmm by r plus h whole square. 1 m cancel with this m, 1 r plus h with this square, and what you got, v0 is equal to under root gm by r plus h. What we got, v0 is equal to under root gm by r plus h. Let's move ahead. Now you see, you got v0 is equal to under root gm by r plus h. Now we know acceleration due to gravity of a planet, small g, is equal to what? Gm by r square. If I'm transferring this r square here, then I'm getting gr square is equal to gm, and therefore v0 is equal to under root of gr square divided by r plus h. This is what? Orbital velocity. What I did, just at the place of this gm, I have substituted gr square. Now, this is what orbital velocity formula we got at height h in terms of small g. Now, if satellite is very close, if satellite is very close to Earth's surface, very close to Earth surface. Then H is nearly equal to 0, and that implies this R plus H is nearly equal to R, we can say. And now you are getting orbital speed P naught is equal to under root of gr square divided by this R plus H is nearly equal to R. So 1R cancel with this square, and you are getting orbital speed is equal to under root gr. And when we have to use this formula, when satellite is moving very close to the Earth surface. Understood? So note down